Okay, looks like we got a medium. Should be, or sorry, an easy. Should be quick. Help apple redistribution into boxes. You're given an array apple of size n, an apple and capacity of size m. Okay. There are n packs where the ith pack contains apples at I apples. There are m boxes as well where the ith box has capacity at I. Return the minimum number of boxes you need to select to redistribute these n packs of apples into boxes. The minimum number of boxes you need to select to redistribute. What does that mean? Note that apples from the same pack can be distributed into different boxes. Okay, so 1, 3, 2, you redistribute. We will use boxes with capacities 4 and 5. It's possible to redistribute the apples as the total capacity is greater than or equal to the number of total. The minimum number of boxes you need to select to redistribute these n packs. Okay, so the number of boxes you need to fill 1, 3, and 2. So fill 6. No, that's not right. Maybe that is right actually. So here 5 by 5 is 15. So you need to use 4, 7, 11, 12, 13, 14, 15. You need to use all 4 boxes. So, I think you, one, need to get the total number of apples, which is the sum of the apples array. And then you just need to use the highest capacity apples. I think you want to sort it, right? Reverse sort it. So it goes from highest to smallest, and then you go through those capacities in the capacity array until you get to a total that is, you sum the values in those capacities until it equals or exceeds the total, and then you kind of look at the index or the number of boxes that implies. So answer, I guess I can say for every box value in the range of the number of boxes, what happens? I assume it's going to be possible. Yeah, it's going to be possible to fit all those things. So I could say in the range of infinity, but I think it does have to be a finite value here. So let's say in the range of the length of capacity. I could also define a variable for that, but whatever. And then what do I want? I want some current value. I guess I can just subtract the current capacity from the total. Total minus equals the, total minus equals the box is the box index, so capacity at this box index, if total is now less than or equal to 0, then break, and then return box plus 1. I think that's right. Apples is not defined. Fair enough, it's called apple, even though it's plural. Okay. And let's see if it works in general. It does work in general. Very good, very good. So summary here. So what's the summer here? The individual counts of apples in apple array doesn't matter. Just the sum or the total of all apples. Therefore, start calculating that. Start by calculating that. And then for determining the answer, which is, or determining the number of, minimum number of boxes to fit all those apples, we'll want to use the highest capacity boxes first. Obviously, if you want to minimize the number of boxes, you pick the biggest boxes. Thus, to identify those boxes, reverse sort the array, so have it descendingly sorted from highest to smallest. Iterate over the box indices, calculating the sum of capacities of box, or alternatively decrement or decrease the total by the capacity, by the current box capacity until it reaches 0. Break when total matches total, kind of. Total apples matches total capacity. Or I guess it should be break when total apples is less than or equal to capacity. And return how many boxes that was, which is like one more than the index. Time capacity, this can be, or time complexity, this can be O of n, log n, in order to do the reverse sorting of the capacity array. Actually, capacity array is m, right? There's m capacities. So it's going to be O of m log n, m log m. Where m is the length of capacity array. And then what? Yeah, determining number of boxes based on that is O of m, the ordinary of those sorted values. So overall, it's O m log m, m log m. Space complexity, this can be O of 1, O of 1, since in place sort, so no extra space needed. Alright, cool beans.